All right, everybody, welcome to Earth Science. Time for the Temperature Range Lab, which essentially is almost the same lab as what you already did with the beaker of sand and the beaker of water. It's in a very real sense the same lab. Now, there's some different ideas, and of course, it's like what's going on in real life versus what's going on in two little beakers in room 212 in Pulaski, New York. So, what I'm going to have everybody do is pick two cities off of a list that's pre done right here. I'll show you where that link is. Pick two cities. One is going to be right next to the ocean, a coastal city. One is going to be inland, a continental city. See where it says it right there? Coastal continental. All right. Critically, they're going to be on the same latitude. Now, I've already gone and figured all that out there for you. If you pick two cities that are next to each other like this, they're on the same latitude. If you decide to be the person that says, "Oh, I'm going to take Boston and Lubbock, Texas," then you're screwing this whole lab up and you're going to be unhappy when I say, "No, I specifically said not to do that. Start over from scratch." So pick two cities that are next to each other. These are pre-matched pairs by latitude. Portland, Maine, and Sioux Falls, South Dakota are on the same latitude. So off that list, which again, I'll show you in a minute where that is and how to do it, you'll pick your two. They'll be on the same latitude. Now, since we're clever enough and we made it through all that seasons and latitude and sun's position stuff that admittedly was difficult, here's the quick review that should be pretty straightforward. If they're on the same latitude, the amount of insulation should be the same. Everything about it should be the same. The angle that it hits at on that given day, and then the next day, a little higher, a little lower, whatever it might be. If you live on the same exact latitude as somebody else, you get the same exact experience with the sun. So look roughly where we live, Eastern Lake Ontario. Come on over to here. Like that area of Michigan, they get exactly Pulaski's experience with the sun. Wisconsin through southern Minnesota. Now, this projection's a little bit off, but roughly our latitude should get the same exact experience with the sun. Okay? So, what's going to be different about these two cities is that one is right near a lot of water, like a lot of water, an ocean. One that's a coastal city right next to an ocean. And the key thing to remember again, this is just like that sand and water lab, which at this point, hopefully, we've discussed a little bit. The sand changes temperature more quickly, the water changes temperature more slowly. And again, I know I said this in another video. You've done that experiment at the beach because if you've been on the beach in bare feet in the sun, you realize the sand's very hot. So you run to the water to cool it off because the water's not that hot. And it would be very weird if it did get that hot every day. Water, key, fundamental to making it through this lab. Water changes temperature very slowly. Not slowly, slowly. Okay. So, what do we got to do here? We got to keep that in mind because what's going to happen is what, like if you're near a coastal city, let's say you end up picking New York City, that's one of the available choices. That's right near an ocean. So all summer that ocean is going to heat and heat and heat and heat very slowly, but it does it. And then it gets to winter. And like I mean you all experience it. You all live like in New York. The temperatures go from like warm to cold pretty quickly. Over the course of a month is a huge difference. The land can drop off very quickly, but the water does not drop off that quickly. The water does a good job of holding on to that energy. It changes temperature very slowly. So, what would you expect if you live near the ocean versus living way inland? Now, I'll give away the lab. I lived in Minneapolis, Minnesota for 2 years, and I expected it to be cold. I knew winters were cold up there. It's in the middle of nowhere. There's no water to keep it warm, there's no major bodies of water. The Great Lakes can do this to some effect. We get to experience this to some effect. Excuse me. Living near Lake Ontario, but the really big one is like you're next to a really big thing of water, like the ocean. Minneapolis is not near any of that. So the winters were, I mean, they were ridiculously cold. I know that we're all very tough here. We're used to tough winters, and it is way snowier here because of the lake effect of the Great Lakes. But it was outrageously cold there, unbelievable. And I kind of expected that. What I didn't expect is that when you got to summertime, it was also really hot. So just like the beach or just like the beaker of sand, continental, we're going to expect to get very hot and very cold. Water or the coastal city won't get as hot, won't get as cold. That's what we're setting out to show. We'll see if we can do it. So back to the survival guide. There will be a link that will say, open this up and pick a pair of cities. Again, please don't do one from here, one from here. And if you want to take, for example, Ocean City and St. Louis, you'll put your initials right there. KF for Kevin Finnerty or whatever your initials might be. You'll put them in that box. It's got to be empty so that we get like these cities spread out through the class. And if you're sitting with a partner, you have to choose a different pair. So if I'm working with my wife, she would have to do up here SF, or my son. They both have SF. Okay. Yeah, that should do it. Now, what you'll do, put your coastal city in there, put your continental city in there. I've got a link set up for you to go to Weatherbase, which I don't have open here. Isn't that wonderful? Pretty easy to use website, though I'll say their search function is not great. So I'd advise going over here to click United States, closing the heads. It's been a little slow today. There we go. And then going to whatever state you have, and then finding the city. I signed up for Ocean City, Maryland, and St. Louis, Missouri. So go to, if you chose those, Maryland, and then you'll get a list of cities. Ocean City. And again, you can try the search feature. It's frustrating. So if you try it for a minute and you get frustrated, just go by this list here. It's way easier. And here's all you got to do. They give us the average temperatures in the top row. We're going to use Fahrenheit, as all of you reminded me in the last lab, because we're Americans. And the graph I did in this one is pre-labeled in Fahrenheit, so don't switch it to Celsius. I don't know why you would. You're going to write down the temperatures, average temperatures for the 12 months. We don't need this one, the annual right here. That's like the overall average temperature. I want to do each month, so January, February, March, and so on. You'll just plug those into the lab, easy peasy. January, February, March. Just plug those 12 numbers in with the name of your city. Go back to Weatherbase. Go back to the United States. Change to your other city. Put those 12 numbers in, and then we're going to graph. Graph is very simple. Don't panic. By months: January, February, March, April, and so on. And if you do that right, we'll end up in December right over here, I believe. Unless I did 2 Januaries. March, April, May. Nope, we end up in December right there. That'll be perfect. Temperatures are over here. So pick two colors, and like we've been doing all year. We should be pretty used to this by now. Move your dot to like 6 or so. How's that look? Good. Dot, dot, dot. Of course, carefully plotted according to the numbers, not just chucking them on there. And when you're done, we haven't been doing very good at connecting the dots. So let's make sure that we do that as a thing. Switch to a smaller pen, play connect the dots, and now 2 graphs. One for each city, color code them so I know what's what. All right? Questions I don't think are too bad. If you take your time and read, you're going to be okay. I want some writing here. This isn't going to be answerable with one sentence fragments. It's really like what the whole point of this lab is. And if you forget what the whole point of this lab is, just go back in this video and it will tell you what the point of the lab is. There are many rate of change questions. If you get stumped on rate of change, you can go back. Actually, I got it open right here. You can go back to the absorption and radiation lab survival guide, step 3 right here. This video tells you how to calculate rate of change. It's my expectation that you can do that by now. If you did it in this lab properly and you did it many times, it should be kind of like we get it by now. Because you're going to do it here, you're going to do it in one of these, you're going to do it for this one, and that might be it. But it's on there several times. All right, questions. I think we're good. Remember how to answer relationship questions. As one thing changes, how does the other thing change? As distance to a major body of water increases or decreases, what happens to temperature range? All right, you guys got this. You can do it. Good luck. So long for now.